I hope you're enjoying the bed lighting. Okay, so we got part of this project. We took apart a dehumidifier. You should watch that, know what's going on. But basically, we got some Arduinos out. Probably going to want to use this guy because he's small and he's cheaper. Okay, so also got a few in here. There's even some smaller chips inside of here that I could use, like this guy. You can get them, they're like AT Tiny 45. Hold on, there's one right here, not in the bag. But let's see if we can get to focus on that. Yeah, that AT Tiny looks like it's an 85, not a 45. Okay, there you go. And you can even program these things super small, use very little power. This is also an option. This is like a, I can't remember, it's like a Pro or something like that. But yeah, I don't like how I can't just plug a USB into it. And they're like the exact same size pretty much, so. I like this guy. He's like my favorite because he's small and usually does jobs I need him to. Okay, so. Let's put these guys back in their static-free bag, which isn't a static-free bag. And we're going to try and find some parts because I got tons of them. Okay, we got displays. I might hook up some sort of display in the future. Okay, we got moisture temperature or moisture sensors. Okay, we got RF, some sort of touch pad thing that I'm supposed to use. Maybe this might be kind of useful because I'm going to be inputting temperatures, but I'm planning on just using my phone or hooking a computer up to it. So I'll probably just use the RF on my phone because I got an RF output on my phone. And we got current sensors right here. This is I don't know if I'm going to be able to actually see that, but it's right there. These things can handle like 50, 100 amps, stuff like that. So let's keep going here. We got motion sensor. This is a sensor which I think I might hook up to it because it's supposed to measure natural gas. Oh, let me put it back on autofocus. It's supposed to measure like natural gas or something like that, and a bunch of other things. I'm going to have to try and figure out which one that is. Movement sensors or whatever. There's a little spring in there. Okay, we got another display. Current meter thing. Okay, let's keep going. We'll find something useful. Okay, here we go. RF. We got our RF, transmitter and receivers. Looks like we got a beeper. I'm going to want this because we're going to want it to be able to make some beeping sounds. I'm probably going to want this, so I'm going to just start putting that stuff over there. Okay, we got more RF stuff. You know, you could use something like this, but if I was going to actually go RF with it, I would use like Wi-Fi. Okay, we got, looks like a barometer of some sort right here. Measures atmospheric pressure. Don't really need that. Here's another current sensor. We don't need that. This is a sound sensor. When sound gets so loud, it triggers. Oh, this goes to one of these right here. Just got this stuff just sitting around, right? Dining room table is like covered with this stuff. Okay, we got distance meter. What is this? Okay, we got an SD card. Don't need that. Got another meter right here. Okay, we got an H-bridge. Found the H-bridge. We'll put that over here in these components. Oh, look at this. Is this the transmitter or is this the receiver? Oh, I don't know. We'll put it over here because it might be easier to just use that as a receiver than wiring up my own. And I have no idea what this is. Oh, this is a XY axis thing. Okay, yeah, I could hook that up, but we don't need that on this. Okay, and then we got humidity and temperature sensor right here. This is like this is my go-to for measuring temperature. It's very accurate, and it does humidity as well. And there's some pre-made software. So we'll be needing this. Let's try and make it so you can read what's on there. There you go. Okay, and we're going to connect all these components up. Oh wait, I already had one out of the bag. Let's put this one back in the bag. Apparently I got two. How lucky am I? Maybe I should put one outside, because I have no way of knowing the temperature outside. We got a really big beeper right here. Look at the size of this beeper, but I think this might be overkill. I just need it to beep when it like receives a set temperature or something like that. That way I know I'm communicating with it. Okay, so So we got my power converter here set up, 5 volts and 12 volts. Yes, I built a custom one because the other ones are junk and useless. Okay, so hopefully you can see it. We got about 70 degrees on there, and I'm going to demonstrate what will happen if I connect this over to here. Should cool down. Yeah, we're already at 61, 60. We're going 50, 40, oh, yeah, 54, 50, 40s, 47, 46, 45, 44, 42, 41, it looks like it will only reach about 20 degrees on the cold end. Ooh, that's cold. Okay, so let's try and reverse that. I think if I tie this one to negative and this one to positive, should reverse it, hopefully. Oh yeah, we're already up to 70, 73, 75, 80, 90, 100, 105, 100, and we're slowing up. So we're around 113. So basically I'm making sure that it doesn't end up getting too hot. Because right now there's nothing on here, so yeah, it's just starting to burn me a little bit. This thing's only fairly accurate because I don't know the surface thing, the value of the E value. I don't know, words, hard, ugh. Okay, so we're about at 115, probably 120, 25 though. Because that's about what it feels like. So I'm going to go with more like what I feel, not what this thing's reading. Okay, so basically by reversing them, it goes hot. Both of them, ground is off. And if I turn both of them on, I'm pretty sure it will short out. So that's how the A and B work on this. I'm going to remove it so you can actually see the wiring here. So let's get focused on there. Yeah, it's the A, and then we got IB and IA. If they're both tied to ground, we're good. And if I put this over to there, it'll become hot, which basically means this one's going to be the negative and the black one's going to be positive. Pull it out, shove this one in. Got them right, okay, good. Then the red one's going to be positive now, and that one's going to be that one. And it'll get cold. Pretty sweet, right? Look at that puppy. And it's got an on and off. Yeah? Yeah. Pretty cool. Okay. So, now let's get into doing the Arduino and actually making it so the Arduino turns this on and off. But, yeah, looks like it's going to work. So, I got some code ready. And you can see it right here. This is all there is to it. Basically, it's just got to turn off, which is turning the heat off. Essentially, it makes it cold. This one makes it hot, and this one does nothing. And then it just rotates through there every 10 seconds. So I'm going to demonstrate what that's like on this thing. Got this thing up and running. I got at least the thing flipping on and off right now. So let's see if I can. It's getting hot right now. Now it's going to go cold. Oh, my battery's going to go dead on my meter. Now it's going to go hot. See? There you go. Oh, it works. Sweet. Okay. So far, things are going pretty good. The only thing is, though, is we're not going to get any decent RF out of this because this receiver is absolute garbage. Garbage, I tell you. Right here. Let's see if we can do a little bit of focusing here. Seriously? Okay, this receiver. Total garbage. Can't receive squat. It's like a foot away, if that. Okay, so that said, things are going along pretty good. This sensor is up and working. I got the temperature control by this device. Hold on, let me take you out of this thing. Okay, so this is what we're looking like so far. We got our H-bridge, our temperature sensor, and then our way to set the temperature. And then we got our arduino. Right here we have this, which right now is hot. And the reason it's hot is because you look right here, see the 74? That's where I got the temperature set, and the temperature is actually below that, which is 73.4. So if I turn this just a little bit when we update again, takes a little bit, it's like 10 seconds I think. There you go, 64. Now it should turn cold. Hold my thumb on it. And there it goes, it's turning cold. So that's all working. So this means I can now set the temperature and test this, even see if this will actually control the temperature pretty good, which I think it will. There's no reason not to. So we're going to put all this stuff on a board, solder it up, and stick it in my fireplace and see what happens. So I got it, for the most part, wired up. I built a prototype board. One of the worst ones I've ever made. Surprised it works. I'm not using the potentiometer. I was using that because I thought the infrared receiver that I was using wasn't going to work. But I was able to get my hands on some, and I hooked this up and I put it in the code, and so on and so on. But that's why this was on here, is because that way I could control the temperature and work with the software. We got an LED here that tells me when I push a button. So push a button, I get it like half a second on there. I put it at, there we go. Okay, and I've just programmed it with a multi-controller thing, and I can also use my my phone because it's got an infrared receiver transmitter on it. But basically, this is the so right now this is fairly hot, and I 3D printed a bracket to hold it on here. This is the bulb, and there's a word for it. I can't remember what this is, but it's a temperature sensor, and this part's the bulb. And essentially, there's a fluid in there, and you heat it up, and it expands, and it changes a diaphragm inside of there, and expands, and it shrinks or whatever, and that controls the temperature. So I got that hooked up. This cord right here isn't doing anything, so we can just disconnect it. There. Alright. So we got our digital thermometer, we got all that, and then I got it plugged in over there. Running off of 5 volts, and everything seems to work just fine. The fan doesn't blow really all that hard, but it does blow, I think, enough for it to work just fine. Now, this is the first version. I'm going to actually upgrade the version to also have wireless connectivity. This is it's a Esp8266 Mod. And essentially it's like an Arduino, only with like Wi-Fi built into it. And it costs like, I think, $5 on Amazon. So, and I'm going to be able to run a web client with this, and I'm going to be able to, from anywhere, be able to check and change my temperature, really from the world over the internet. So I'll just put in my IP address, and this will have HTML in it, CSS. It can run JSON. If you install it right, there's tutorials online. It can also do like JavaScript, stuff like that. But we'll get into the code, I guess, that's running on there, but that's pretty much how it works. And I got up and down on here. Right there, I just set it to 60 degrees, and that sets it to 70 degrees. Because when I sleep, I keep it at 70 degrees, or 60 degrees, and then pretty much 70 degrees during the day. And then these move it up and down half a temperature. And I can program any of these other buttons to do anything else. So I could have like 65 degrees or maybe like 55 degrees there, whatever. But you could program that in there, and I'll show you guys the code. So I'm gonna try and do the best I can with this recording of my screen. So what we have here is we have the code that I'm running. This is the code that I'm running. Okay, yeah. Okay, and we're setting the up arrow in the sleep, which is the 60 degrees, and the normal, which is 70 degrees. These are the hex numbers that I got off the remote by using the record example library that came with whatever software I'm running. I'll add that in the link. Okay, so we got heat, false. These are the defaults. We got some booleans. We got some unsigned longs, 32-bit values. Oh, excuse me. All right. We got some float values for the temperatures, and then we're setting. These are the pins we're using. Analog 0 isn't being used anymore because that was for the potentiometer. Pin 8 is the green LED that would turn on when I push the button, and pin 10 and 11 are used to on the H bridge, and pin 13 is to tell me if basically it's on or off, essentially. So pin 13 lights up when the heater should be turning on. In other words, when the thermal thing turns cold. Okay, and then we got on the receiver, there's a diagnose debugging feature, which is uses pin 13. You set that to true, and when it receives any type of signal whatsoever, it will blink. We then enable the receiver right here. This is beginning the temperature sensor. We do a temperature read, and we put it in RE temp, which is for retemp, I guess. Okay, and then I used to have these counters here, but they're not used anymore. But I used to have these counters. They would be set to. They used to be like +1s, but I left them here like this. I can't remember why, but I think it was so I could copy and paste them or something. Yeah, that's what because I copied and pasted them in here. Okay. But basically, this one right here, for example, the receiver is disabled for a while after the button is pushed, because that's what automatically happens after it receives the signal, is it disables itself automatically, and it has to be enabled. Okay, and then received also turns to true, and essentially when receive is true, the 8 pin is high and the LED lights. So this, after 50 milliseconds, half a second, it turns it false and it's ready to receive again. Okay, here we have it, because what I kept having a problem with is when the signal was far away, what would end up happening is it would keep going through its loop inside the loop function inside the Arduino sketch. But what would end up happening is, for some reason, it would stop receiving, even if I enabled it. And this would only happen if I was outside of range, so it's getting incomplete signals. So what I did is every 4 seconds, I disable it and then re-enable it. And that's just to help deal with that. I guess it's like a bug, or maybe I'm not using the code right, but that's just how I'm dealing with it. Okay, so what we're doing is we're checking for results, and we're getting them. So if there's results, this if statement will run, and then it decodes the results, and then it checks to see if it's a repeat value. So if it's a repeat, whatever is the decoder value, then what will happen is it will simply run this code. It won't run the else, and it will skip down here and it will just use code value. If it isn't a repeat and it's a new one, and this is important because ENC, the protocol for that, and this is something I had a big problem with it when it came to receiving. It doesn't resend this exact same code over and over again, so if you double push real quick, or if you hold down the button at all, what will happen is it will send out a nothing but ones in the thing. So it will be like, the hex will be like F, 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 F. And so the thing is that's meant to be seen as a repeat code when it comes to NEC. Well, my program was not recognizing that hex, so it would come in here, receive it, and then it would do nothing. And it was causing me to not be able to receive signals most of the time. So that's why that's there. And as you can see, arrow up, it raises the temperature, because this is the temp that I want, by 0.5, and it lowers it by this, and then you can see sleep, 60 degrees, normal 70 degrees. And you can see it sets received true, and it sets counter. This is the very first counter, which is why it's just counter, 2 mils. And that way, which you can see right up, that's counter 2. There's counter. So you can see that's the half cycle one. So we turn receive defaults and we re-enable it, and so on and so on. Okay. So now that we got that out of the way, we can also see where it says received right here. And if it's true, it turns pin 8 high, and if it's not true, it's else, which means it turns it low. Okay, and then we got some serial out here if we need it. Then we got counter 3, which basically is for reading the temperature from this. That way there's no point in reading the temperature just every single time it goes through the loop. That's just kind of dumb. So we got a counter right here for every 5 seconds. It will read the temperature. And then this checks to see if it's heating or not. Heat is true when it runs the on right here, the function on. And then it also writes the pin 13 high. That way we can see that pin 13 will be high. So we can see right here that this needs to be false, which means it's off. So that way this isn't running, we're not running the on feature and all this other stuff. So we want to make sure that we're actually changing temperature and not just, okay, yeah, this temperature parameter meets and we're running all this code, and it runs a bunch of functions as well. So we don't need to reset the thing high, and we don't need to run the on and stuff like that. And this is essentially for turning it off, which is the reverse. But as you can see down here, we got turn off, which runs a function called shutdown. And this is one of the reasons we don't want to run it every single time, because it actually shuts it down, and it actually waits a really, really small, like it's 1 millionth of a second. And then it essentially writes pin 11 high, and this is for the off state. And then pin 10 is high for the on state, and again we got the delay, and it also shuts down. And then the shutdown, it basically, it turns both these pins low. And the reason we have that really small delay is, and we could probably increase it, or probably should, because the transistors need a certain amount of time on the H-bridge to actually shut down. So we got the transistor that actually has to turn off. These pins right down here, they actually have to shut down low. Otherwise, because if both of them are high at the same time, it shorts. So we actually need a delay in there to make sure we don't accidentally short the 2 transistors on the H-bridge. So this is essentially the code, and I'll try and put it up in maybe the description or a link in the description or something like that. But this is basically all there is to it. It's fairly simple and straightforward. I haven't really cleaned it up that well. But other than that, it works just fine. And I will begin working on step 2 of the project, which involves Wi-Fi and web clients and stuff like that. But so far this version works just fine. So that's all there is.